In this lesson, I will talk about the loading of data from a Snowflake perspective. First of all, loading means that the data will be stored in a table. It will be modified also because in Snowflake, the data has to be splitted into micro partitions before being stored. The data has also to be encrypted and compressed. So it is different from a stage because in a stage, the data is stored as a raw file. The most modification that we can do in a stage is compression. There are two strategies to load data in Snowflake. The first one is bulk. Here, a complete file is loaded. It is a synchronous loading because when you load data with a bulk strategy, you have an output results from the loading. The bulk loading is made using the copy into table command, and this command can be scheduled with tasks. The tasks can be configured to work serverlessly or to be configured to work with a user-defined compute, so a warehouse. The second strategy to load data in Snowflake is continuous loading. Here, the data is loaded as soon as it is generated. It is an asynchronous loading. That means that you won't have an output results and you have to observe explicitly the loading. The continuous loading is possible using Snowpipe streaming, or the Kafka connector. It works only in a serverless way. So that means that all the components used in Snowflake, for example, the Snowpipe streaming API, do not require a virtual warehouse in order to work. Next, let's display once more the ingestion schema. And let's do a focus on the loading of data. So the loading of data represents these flows. So you have the external stage that will be loaded into tables. And this is possible with the copy command and the Snowpipe technology. You have also the internal stage that you can load into a table. And this is possible also with the copy and the Snowpipe technology. Next, concerning the streaming sources, you have the Kafka that can be loaded into a table with the Kafka connector. And you have also other streaming sources that can be loaded into a table with the Snowpipe streaming technology. All these technologies will be deeply discussed in the next lessons. But first, we have to know how do we have to prepare our file before loading. So the first thing we have to know is that the supported file formats for table loading are delimited: JSON, PowerK, ORC, Avro, and XML. It is different from stage because in stage you can store whatever you want. But if you want to load data into a table, the source data has to be in these formats. So delimited, JSON, PowerK, ORC, Avro, or XML. Next, concerning the file sizing. The recommended size for the files are from 100 megabytes to 250 megabytes. It is the recommended size because it is the perfect size for parallelization without generating overhead costs in the warehouse. Overhead costs in the warehouse can be generated when, for example, you have too many files that cannot be processed in parallel. It is the recommended size because it is also good for loading files without generating overhead costs in Snowpipe. So the perfect file size is file size that has a loading time equal to 1 minute. Also, for a very large file like 100 gigabytes, the on-error copy option is highly recommended because it offers the possibility to continue despite a controlled number of errors that you have to specify with the on-error copy option. It is highly recommended because a small number of errors could prevent the whole file to be integrated, and then this could cause waste of credits. Because let's imagine that you have a big file, a very big file of 100 gigabytes, and you have only one line that has an error. Then if you don't provide the on-error copy option, then the copy will fail and then the whole file will be rejected, and then all the work that has been done so far will be canceled, and then the result is that you waste your credits. Another recommendation concerning the file sizing is that you have to study the possibility of splitting large files. Also, you have to study the possibility of aggregating small files because too much small files can cause processing overhead. The recommendations concerning the JSON file are if you have an array at the first object of your JSON file, well, it is preferred to remove it because if you remove the first array, well, it will produce multiple lines and you will not be blocked with the 16 megabyte limitation for each rows. It is possible with the strip outer array parameter in the copy into table command. For the limited file, the number of columns should be the same for every row. Otherwise, you will have errors that will be thrown if you don't have the on-error parameter. Fields that contain delimiter characters should be enclosed in quotes. Fields that contain carriage return should be enclosed in quotes too. Concerning the numeric values, you have to separate the fractional parts with a decimal point. For example, 123.456. For date, time, and timestamp data, you have to use a format supported by Snowflake to prevent errors during loading. Now let's talk about the warehouse recommendations when you load data. The first recommendation is that you should separate warehouses for loading and warehouses for querying. And this is in order to optimize the performance, in particular when loading large datasets. Generally, a small warehouse is enough to load multiple files in parallel. Because the size of the warehouse is linked to the number of cores, and each core can take care of one file, then every warehouse can handle multiple files. And even with the smallest warehouse, you can handle multiple files that can be loaded in parallel. That's all concerning the loading data session. I hope it was pretty clear, and I will see you just right after.